So this is not a function because if I draw a vertical line, it hits it in two places. The domain are the x values. So if I look at the graph, the smallest x value is 1, and then it shoots off, so it's greater than or equal to 1. And the range, again, this just keeps widening up. It's a parabola on its side. So the range for that is all real numbers. Our next one, we have this oval. It's not a function because if I draw a vertical line, it hits it in more than one place. The domain for this, so hopefully on your paper you can see it a little bit better. It goes from -1 to 1, I think. I can't even see it well. Yeah, -1 to 1. And the range, or the y values, the smallest y value is -2, the greatest y value is 2. Okay, for our next graph, it's a function. It starts right here, and then it goes this way. So it is a function because if I draw a vertical line, it's only going to hit it once. My domain for this is x is 0 or greater. So x is greater than or equal to 0. And my range for this one, well, the lowest y value is -1, and then it goes up from there. So y is greater than or equal to a -1. The next graph, it's a function. You draw any vertical line, it's only going to hit it once. The domain are the x values. So it just keeps widening out. So domain is all real numbers. And my range, it shoots down to -infinity here, it's shooting up to +infinity there. So my range is all real numbers. And then the last graph one here, which is the absolute value graph, it is a function. The domain or the x values are all real numbers. And the y values, the lowest y value it ever takes on is 0, and it goes up from there. So the range is y is greater than or equal to 0. And again, these are all typed out for you on your notes as you go through. But when you're looking at things, try and cover it up, take a look at yourself, and then go back and compare the answers. All right, we have plotting points to graph a function. And these are all put out for you. We're not going to be spending a lot of time just plotting points, but some functions you just don't know what they look like, or you just want a better idea of what's going on with them, and you want to actually plot some points. And that's the best thing to do. If you have nowhere to start for your function, just pick some x values, plot them, and see what plug them in, see what the y values are, and then graph them. So I have that y equals the absolute value of x minus 1, just plotting some points, and then plotting the points over here, sorry. Take the x values, evaluating them to find the y, and then plotting the points. So that's what my absolute value graph looks like. And then I have a quadratic, y equals x squared plus 1. Again, I just put in some points, find the y values, and then I plotted it out. You don't have to do this by hand anymore. So if you have a graphing calculator to use, or you can use Desmos as a system that is really easy to plug stuff in to plot it for you. So there's only a couple more things that I want, and I wanted to go over the couple more problems for composition of functions that are a little messier. So I have f of x is 1 over x minus 15, And g of x is x squared plus 15. So I want to first of all find a new function that I'll call h, that's g of f of x. And then I want to know what that is evaluated at 16. So first I'm going to do the g of f of x. I'm going to take the g function, which is x squared plus 15. And instead of the x, I'm going to plug in the f of x function, which is 1 over x minus 15. Now that I have that, I want to evaluate this thing at 16. So I'm going to plug in 16 for x now, and I get 1 over 16 minus 15 squared plus 15. So 16 minus 15 is 1. So 1 over 1 squared is 1 plus 15 gives me 16. Now I want to do the same thing but in the opposite direction. So I want to find f of g of x and then evaluate that at 16. So this time I have the f function first, which was 1 over x minus 15. And I want to plug in for that x the g function. So I have 1 over x squared plus 15 minus 15. And 15 minus 15 is going to cancel, so that's just going to give me 1 over x squared. And then I want to evaluate that at 16. So I have 1 over 16 squared, which is 1 over 256. And then the last one I have f of x is 6 square roots of x. And I want to find f of a plus h minus f of a over h. So each of these pieces I'm going to plug in a plus h. So first I get 6 square roots of a plus h because I'm plugging that in for x, minus 6 square roots of x because 6 square roots of a, sorry, because minus f of a, so I'm just plugging in a for that, all over h. Now we're going to be doing a lot of this when we're doing derivatives, and we're going to have to rationalize it. So I'm going to rationalize this thing to get the radicals out of the numerator. So I'm going to factor out a 6 first. And then I'm going to multiply by the conjugate. So that's how we had to get rid of the radicals. We did the conjugate. So I'm going to multiply the top and the bottom by the square root of a plus h plus the square root of a. So whatever that sign is, we have to do the opposite sign in order to change it. When I multiply that out, square root of a plus h times the square root of a plus h is just going to be a plus h. Minus square root of a times square root of a is minus a. And the middle terms cancel. That's why we picked it. You get negative a plus h, positive square root of a plus h. So those two just cancel each other out. And then on the bottom, I have h times square root of a plus h plus square root of a. This a minus a there cancels, and I'm left with 6h on top. And then the h's simplify. So it simplifies to 6 over square root of a plus h plus the square root of a.